find the velocity when it hits the ground. So we got a lot of these concepts that are the same. As we previously looked at, but now we're using the antiderivatives to help us out. So remember, it's going to hit the ground when s of t equals 0. So number 1, we're going to set s of t equal to 0. So here we go. We know what s of t is. It's negative 16t squared plus 16t plus 32. We set that equal to 0. I'm going to factor out a negative 16. When I do that, I got t squared minus t, and then minus 2 equals 0. Divide both sides by negative 16. You got t squared minus t. Minus 2 equals 0. We can factor that to t minus 2 and t plus 1. So we found that we got t minus 2 equals 0, t plus 1 equals 0. Add 2 on both sides, subtract 1 on both sides. We can't have negative time, so our time when it hits the ground is 2 seconds, but the problem is asking us to find the velocity. So we need to substitute in to the velocity here. I guess I should say find velocity. Remember, our velocity function was negative 32t plus 16. We want to know what the velocity is at 2 seconds, so we got minus 32 times 2 plus 16. Minus 32 times 2 is negative 64 plus 16. That gives you negative 48. And then that's feet per second because it's velocity. All right, and that's the velocity when it hits the ground. And there we go. So we can apply our old techniques that we had to find some of the same concepts. And we can use the antiderivative to really help us out if we're given that the only acceleration is due to gravity. Okay, see you in the next